Hi, in this playlist we're going to be looking at the Edexcel, and it's the Higher Paper 3, which is the calculator paper from the June 2018 series. Like I've done with the previous videos on the other playlists, I'm going to work through for about 20-25 minutes or so. Please do stop the video, have a go at each of the questions and then compare your solutions. And we'll aim for this video to be about 20-25 minutes in length. Okay, hope that's all right for you. Let's move on then to question number 1, which is a scatter graph. Okay, every time you see a scatter graph, the chances are there's going to be something to do with the line of best fit. So I'm actually going to draw that in, even without reading the question. So the whole idea with that is that we put a line in here that will give us some area or some line which is roughly equidistant between each of the points. It's not an exact science, and there is quite a lot of leeway on these types of questions. So the first question is, scatter graph shows information about 12 girls, shows the age of each girl and the best time she takes to run 100 meters. Okay, and part A of this is write down the type of correlation. Well, this is actually a negative correlation. It's going in the opposite direction to the positive. So effectively what we're saying is that the time is quite high for younger age groups. So as they get older, the time decreases, and we call that a negative correlation. So I'd write that just in the bottom here. Okay, so it's a negative correlation. Okay, so the next part of the question that it says is that Christina is 11 years old. The best time it takes to run her race is to run 100 meters is 12 seconds. The point representing the information would be an outlier on the scatter diagram. Explain why. Well, as you can see here, what I've got is the ability to just put this in. So she's 11 years of age and she ran the 100 meters in a fantastic time of 12 seconds. So she definitely is extremely quick. Okay, and basically it says, why is this an outlier? Well, all we're saying with that is that it's just outside the normal range. Okay, so on the actual paper itself, I would just put something like outside the line of best fit. So outside the line of best fit, and it's absolutely fine if you use a different sentence, but basically that's what they're after you writing down. Okay, so the second part of it says Debbie is 15 years old. Debbie says the scatter diagram shows that I should take less than 12 seconds to run 100 meters. Okay, well, you've got a comment on that, and I think one of the things that you've got to be a little bit careful of, and these questions are very, very similar, is that the reality is, if we go back to the scatter diagram, it only actually gives us data up to about 13 3/4 here. So actually Debbie can't really say that this line is going to continue for her because she's 15 years of age, and that's basically what they want you to write onto these things. So what I would say is that something like it's outside the range of data available. So outside the range of data available. Okay, and again, you can expand on these sorts of things. You could put the scatter graph only represents the data of 12 girls and doesn't include Debbie. Okay, so you can elaborate on that a little bit if you want, but certainly for 1 mark, I wouldn't spend a massive amount of time on that. Okay, so question number 2, we've got to expand and simplify, and we've got this expression here to simplify. Now, the thing you need to be careful of with these sorts of things is this middle bit. Okay, it's that negative that makes things just a little bit more difficult for you. So the first part of it is relatively straightforward. I can multiply 5 by p and then 5 by plus 3. So what I'm going to get is going to be 5p plus 15. And that's basically 5 times p and 5 times plus 3. Okay. However, now I've got minus 2 times 1. So minus 2 times 1 is going to be minus 2. But then I've got minus 2 times minus 2p. Well, a minus times a minus is a plus. So I'm going to end up with plus 4p. So be very careful about that. The reason these types of questions are 2 marks is because usually a good proportion of students will miss that negative bit. So you're going to have to be a little bit careful with this to get that full 2 marks. Okay, so all we need to do now is just tidy that up. I'm going to gather up the 5p and the plus 4p. So that's going to give me 9p. And then I've got plus 15 minus 2 is going to be plus 13. And that would be the answer to this particular question. Okay, so on to question number 3, and it says here is a trapezium drawn on a centimetre grid, and what they want us to do is draw a triangle that is equal in area to this trapezium. Okay, so it's not actually that straightforward. You could potentially count up all the squares and work out the area, but you've got this sort of difficult one going on here, and it might prove to be a little bit problematic. So I think what they're looking for you to do is actually use a couple of formulas. So what we can do first is work out the area of the trapezium. So this is the trapezium itself. Okay, now the formula that I use is a half a plus b times h. Okay, and what we mean by that, if we go back to the trapezium itself, this would be the value of a, which is this line along the top here. This would be the value of b, and then h is the height of the trapezium overall. Okay, so let's plug those numbers into this particular equation, and hopefully we can come up with an answer for the actual area that's taken up. So it's going to be a half. Now the value of a is the top line, which is 2, and then the bottom line, which is 7, and then h is going to be 4. Okay, work that out. I've got 2 plus 7 is 9, multiplied by 4 is going to be 36, then multiplied by half is going to be 18. So actually, and very neatly, the trapezium area works out as 18. So what we're going to do then is change that to a triangle. Well, the area of a triangle is going to be a half base times height. Okay, so that's a half base times height. Now some people will use base times height over 2, and that's perfectly fine. Doesn't really matter. It's exactly the same calculation, because what we can do is we can say, well, actually I'm going to make the triangle area to be exactly the same, but this time I've decided I'm going to make the base 6. Okay, now the reason I'm going to do that is that it just makes my calculation a little bit easier, because 6 times h is 6h, and then a half times 6h is going to be 3h. So what I've got now is 18 equals 3h. So if I want to work out the height of the triangle, it would be 18 divided by 3, so that's going to be a height of 6. So now I've got my triangle with a height of 6 and a base of 6, and it just makes the actual drawing a little bit easier to do on the grid. So the base is going to be along 6, so 1, 2, 3, 4, 5, 6, so that's from there to there, okay, and then it's going to be a height of 6, so 1, 2, 3, 4, 5, 6, so it's up to there, and then basically draw all of those lines connected, and I should have a nice triangle. Now I've chosen an equilateral triangle. Oh no, I haven't. Yes, I have. Okay, I've chosen a triangle with a height of 6 and a base of 6. Okay, all righty, there we go. It's actually an isosceles, it's not an equilateral. Sorry about that. Okay, so hopefully that's okay for you, and your calculations will be broadly similar to mine. Okay, let's move on then to question number 4, which is a question based on probabilities. Now, probabilities do actually come up quite a bit in Edexcel boards, so it's worthwhile, particularly probability trees. I do tend to see these a fair amount. Okay, so from the text it says when a biased 6-sided dice is thrown once, the probability that it will land on a 4 is 0.65. So that means then that the probability it won't land on a 4 is actually going to be wrong here. It's actually going to be 0.35 because these two probabilities need to add up to 1. Okay, so straight away I've just read the first sentence and looked again at the diagram, and it should be 0.35. Okay, so that's the first thing. And then it says the bias dice is thrown twice. Amir draws this probability tree diagram, and the diagram is not correct. Okay, well, we've spotted the first one, so two things that are wrong. The first one is that the probability, so the first probability needs to add to 1. Okay, so and they can clearly see on the diagram that actually I've changed that 0.25 to 0.35. Okay, the second one is that probably if we look in the second series of probabilities, there'll be something wrong with that, and indeed there is, because you've got this situation where it's actually being swapped around here, because the probability of landing on a 4 should be 0.65, because it's going to be exactly the same, because exactly the same dice has been thrown. So while he's got it absolutely right here, he's not got it right here. Okay, so the second throw, if I put second throw, land on 4, incorrect. Okay, and again they can clearly see from the diagram that that needs to be the other way around. I hope that's been okay for you. Let's move on then to question number 5. Okay, in question number 5 we've got SohCahToa. Okay, and we're working out the size of a right angle, or the size of an angle in a right angle triangle, which is actually this size, this angle here, which is ABC. Okay, so with all SohCahToa type questions, firstly you need to recognize that it is a right angle triangle, and therefore we can use the ratios of SohCahToa, and I'm fairly sure that people might have different ways of remembering this. I just remember it as a bit of a rhyme really, but there are other ways I'm sure that you could remember that. Okay, so let's have a look at what we've got on the triangle. Well, the first thing is we're trying to find out this angle X. Now opposite this angle X is this line here. Okay, so this is actually the opposite. Now I always do this exactly the same way, that I first work out the opposite, and then I work out the hypotenuse, which is the longest line, and then I work out finally, or I write in the adjacent. Okay, so now I've got my 3 sides of the triangles labelled up. I need to decide whether I'm going to use sine, cosine, or tangent. Well, actually, I'm going to use cosine. Now, the reason I'm going to use that is because I know the adjacent, and there it is, and I know the hypotenuse, and there it is. What I do need to find out is the angle. Now, this will allow me to calculate the cosine of the angle, and then I'm going to convert it back again. Okay, so let's pop that into a calculator, and I would write cosine to -1, which is on the shift key. So shift cosine will give you the inverse trigonometric ratio, okay, and that will allow you not just to calculate the cosine, but actually to then change that to the angle itself. And I can plug in the adjacent, which is 7, divided by the hypotenuse, which is 11, pop that into my calculator, and I should get an angle of 50.4788 degrees. Okay, now just be very careful about these sort of things, because the question does ask you to write the answer correct to 1 decimal place. So to 1 decimal place, it's an answer of 50.5 degrees. Okay, so be very careful about that sort of thing to make sure you get both of the marks for that question. Okay, so part B of the question, it says the height of side AB is reduced by 1 centimetre. The length of side BC is still 7. Angle ACB is still 90. What's the value? Will the value of the cosine increase or decrease? Well, actually, you know, you can just plug this into a calculator, because really what we're saying is that we've got cos of, I can do -1, it wouldn't really matter, but 7/10. Okay, actually I'll leave that as cosine. If you compare the two cosines, what you'll get is that this is a larger value than the cosine of 7/11. Okay, so you can just compare those two in a calculator and that'll work out absolutely fine for you. Okay, so on to question number 6, and it says there are some counters in the bag. The counters are red, white, blue or yellow, and Bob is going to take a random counter from the bag. Okay, so what we're told initially is that there are 18 blue counters in the bag. So we're saying here that there are 18 of them, is that particular sentence there. Now, if that is the case, it allows us then to work out the total number of counters in the bag, because the probability of taking a blue is going to be 0.45, but it's 0.45 times the total number of counters. In other words, nearly half, if you like, of the counters are blue. So 0.45 times the total number of counters. Okay, now the total number of blue counters, we're told, is 18. So 0.5 times t is going to be equal to 18. Okay, and we can use that fact to work out the number of counters overall in the bag by dividing through by 0.45. So therefore it tells us that there must be 40 counters in total. Okay, so we know that all of these counters added up together are going to equal to 40. So we can look also then using a similar principle to the yellow counters. Now the yellow counters, we know that 0.25 of the 40, if you like 25% of the 40 are going to be yellow. So therefore 25% of 40 means there must be 10 counters that are yellow. Okay, so let's have a look at the next bit. It says the probability that the counter Bob takes will be red is twice the probability that the counter will be white. Okay, well the only way really of doing that is to say that if the probability of taking white is x, then the probability of taking red is double that, which is 2x. Okay, so we're in a position now where actually we can put together a little formula based on all the information we've got in order to work out the value of x, and that will tell us how many white counters there are, and then we can double it to find out how many red counters. Okay, so let's have a look at that. So what we're saying is all of these added together, 2x plus 28 is going to equal to 40. Okay, so we can write that. We've got 3x plus 28 equals 40. 40 counters in total, 28 of which are either blue or yellow. Okay, minus 28 from both sides, and I'm going to get 3x equals 12. Okay, divide through by 3 and it means I get x equals 4. So what this is telling me now is the value of white counters must be 4 and the value of red counters must be double that, which is 8. So this will be 4 and this will be 8. So to answer the question, the number of red counters will be 8. Okay, so let's look then to part B, or the second part of this particular question. And it says a marble is going to be taken at random from a box of marbles. The probability the marble will be silver is 0.5. There must be an even number of marbles in the box. Okay, it's one of those sort of 1 mark sort of throwaway questions that they usually have at the end of these sorts of exams. Okay, what we're basically saying is that half of the marbles are silver. Okay, so half of the marbles are silver. Okay, that's when it says the probability that the marble will be silver is 0.5. Okay, so then that must mean then that half of the marbles are other colours. Okay. Alrighty. So if we're saying then that the half of the marbles are silver, there must be an even number of marbles within the box, because to divide by a half and actually have a number, there must be an even number of marbles. Okay, so you might want to try just a few examples if you want to, but to be honest with you, for a 1 mark question, I think that would be sufficient to write something like that, and maybe it's something you could check if you have time towards the end of the exam. Okay, so I hope you found this first video useful. We're looking at the June 2018 paper 3 for Edexcel. This is the first video, and there's going to be a few more videos in the playlist where we're going to start from question number 7 onwards. I hope you found it useful. Please do add a comment below, subscribe to the channel, and I'll look forward to seeing you inside the next video.